Hi, my name is Roger, and this is Mr. Rogers' Math Corner, where I help you solve problems you will definitely see in class. Today we're going to do systems of equation elimination method. Now, if you want to see systems of equation graphing method, I linked the video here. And if you want to see the substitution method, I linked the video here. Okay, so now let's look to show you how we're able to use the elimination method. Just take a look at this. I have 3 plus 4 is equal to 7, and I have 5 plus 1 is equal to 6. These are two legitimate equations. Well, let's see what happens when we add them. So 5 plus 3 is 8, and 4 plus 1 is 5, and 6 plus 7 is 13, and 8 plus 5 does equal 13. So when you have a legitimate equation and you add it to a legitimate equation, you get a third equation which is legitimate. So that's how we're able to eliminate one of the variables. Remember, the goal is to eliminate one of the variables. I have an equation with two unknowns, and I have another equation with two unknowns. And the x's are the same and the y's are the same, but I have two unknowns. Can't solve a problem with two unknowns. Matter of fact, the solutions are infinite. But if I use the equations against each other, I can eliminate one of them and therefore just have an equation with one variable. And we should be able to solve any algebraic equation with one variable. So let's look at this. Look at what's going to happen when I add these two. I have a negative 4x and a positive 4x. Well, when I add those, they zero out. And that is your goal with the elimination method, is zeroing them out. So then I'm only left with a y and a constant. So now I add my negative 2y and my positive 8y. That gives me a positive 6y. And I add my negative 12 and my negative 24, and that gives me negative 36. Okay? And we know how to solve this one easily. We divide both sides by 6, and I get y is equal to negative 6. Now remember, with any systems of equations, I haven't finished yet because I have to get both variables. Right now I've only solved for y. So how do I solve for x? Well, what I do is I take either one of these equations, it doesn't matter, and plug in the negative 6 for my y. So I'm going to use the bottom equation. So I have 4x plus 8 times the y value that I now found, which is negative 6, is equal to negative 24. So positive 8 and a negative 6 is negative 48. So my equation now is 4x minus 48 is equal to negative 24. Okay, I'm going to add 48 to both sides. Okay, and I get 4x is equal to 24. And again, I'm going to divide both sides by 4, and my x is equal to 6. So now I've solved for both variables, and I write my solution like this. 6 comma negative 6. We write it the way we write any coordinate, okay? So it's x comma y in parentheses because the answer is a coordinate. So 6 negative 6 is the solution to the systems of equations. If I plug that into either equation, it will solve them. Well, this was an easy equation. I call these being teed up for you. So in other words, all I had to do was add the two equations and the x's eliminate. What if I have an equation like this where they don't eliminate? Okay, notice I have negative 3x and a negative 9x. If I add them, I get negative 12x. And I have a positive 7y and a positive 5y. If I add those, I get a positive 12y. Nothing has eliminated. But what I'm going to do is I say, gee, look at this negative 3x. If that was only positive 9x, it would eliminate with the negative 9x. So what I'm going to do is I'm going to change it into a positive 9x. How do I do that? Well, I will multiply that by negative 3, because a negative 3 times a negative 3x is positive 9x. But in order to be algebraically correct, I have to multiply everything by negative 3. If I only multiply one part by negative 3, I've ruined the equation. So now I do the distributive property. Okay, I multiply. So negative 3 times negative 3x is a positive 9x. Negative 3 times positive 7y is a negative 21y. And negative 3 times negative 16 is a positive 48. Okay, all right. So the bottom equation, nothing changed from that. So I'm just going to rewrite it as it is. negative 9x plus 5y is equal to 16. Okay? All right. So now my x's eliminate. My negative 21y and positive 5y leave me with a negative 16y. And my positive 48 and my positive 16 gives me a positive 64. So when I divide both sides by negative 16, y is equal to negative 4. Okay. Now remember from the last one, I've only solved one of them, so I have to solve for the x. I pick either equation. As a matter of fact, I could pick my new equation also. I have 3 equations to choose from, but I'm going to choose the top one on the left. So I have negative 3x plus 7 times negative 4 is equal to negative 16. Well, 7 times negative 4 is negative 28. So I get negative 3x minus 28 is equal to negative 16. I'm going to add 28 to both sides. Okay. And I end up with negative 3x is equal to positive 12. And when I divide both sides by negative 3, I get x is equal to negative 4. So it turns out my solution is negative 4, negative 4. Okay? That point, negative 4 and negative 4, will solution both of these equations. And so it is the solution to the systems of equations. Now, what if I have a situation like this? Okay? And matter of fact, if I multiply the top one by anything or the bottom one by anything, I'm still not going to eliminate any one of the variables. But I look at this and I say, that 5x I could turn into a positive 15x, and that 3x I could turn that into a negative 15x. In other words, I'm looking for the least common multiple of a 5 and 3. Okay? So I'm going to multiply the bottom one by negative 5 to turn that into a negative 15. And I'm going to multiply the top one by a positive 3, which will turn that x into a positive 15. Okay? Notice that I have to do it to both, to the entire equation. Okay? I have to do the distributive property. So 3 times 5x is 15x. 3 times positive 4y is positive 12y. Okay? 3 times negative 30 is negative 90. Now I do the bottom one. Negative 5 times 3x is negative 15x. Negative 5 times negative 9y is positive 45y. And negative 5 times negative 18 is positive 90. Okay. Let's put a nice straight line under there. My x's eliminate. My y's turn into be positive 57y. But it doesn't matter because negative 90 and positive 90 is 0. So therefore my y is 0. Okay? And again, I've got to go back to any one of the equations. I'm going to pick the upper left again. So 5x plus 4 times 0 is 0. So it's 5x plus 0 is equal to negative 30. I divide both sides by 5, and I get x equal to negative 6. So the solution to this one is negative 6, 0. So we've seen all 3 cases, okay? The first case, I call this teed up for you, really easy, because all you do is add them and one of them will eliminate. The second one, I had to multiply the top equation by a negative 3 to turn that negative 3x into a positive 9x so that it will eliminate when added to the negative 9x. And on the last one, this is a situation where you have to multiply both of them. By the way, I could have, if I wanted to, multiply the top one by 9 to get 36y and the bottom one by 4 to get negative 36y. All right, I could have done that also. But in this case, I decided to multiply the top one by positive 3 to turn that 5x into positive 15x, and the bottom one by negative 5 to turn the bottom one into negative 15x, so they will eliminate. So that is your systems of equation elimination method. And now, the math joke of the day. What did the triangle say to the circle? You're pointless. My name is Roger. This has been Mr. Rogers' Math Corner. and we'll see you next video.